transformations, and we're going to look at graphs on this, but it is stuff that you have seen to some extent before. So, in general, if I am talking about something that's exponential, it's of the form f of x equals a to the x. A is just a positive number other than 1. So it's a constant. X is, of course, your variable. We call that a our base and the x the exponent. So if it's exponential, then the key is the variable is in the exponent versus the equations we've seen so far, like x squared, x cubed, where the variable was the base. So that is the difference here. Alright, so let's take a look at this. We are going to look at two different exponential functions, 2 to the x and 1/2 to the x. And we're going to compare those things. Okay, so we know when we're graphing we can make t-charts. So if I want to graph 2 to the x, what should I plug in for my x? 1. So 2 to the first is 2. If I put in a 2, 2 squared is 4. Okay. What else? Yeah. What is anything to the 0 power? 1. Is that enough to tell what my graph's doing? Maybe not. Let's put in like a -1 and -2. A negative flips, right? So if I have 2 to the -1, what that means is 1 over 2. So 2 to the -1 gives me a 1/2. If I put in a -2, 2 to the -2 means 1 over 2 squared. So we would get 1/4. Can you tell what's going on now? Will you ever do 2 to a power and get 0 for an answer? No. So what happens is the graph looks like this. The x-axis is a horizontal asymptote. We're getting close to it, but not actually hitting that value. Questions? I asked some other questions about this. What is the domain of that function? Domain, if you go left to right, negative infinity to positive infinity. Range is your y, so going from the bottom up, this thing starts at 0. Does it ever actually hit 0? No, and then keeps going up, so be a parenthesis on the 0, comma, infinity. Is this function increasing, decreasing? Increasing the entire time, so it's increasing from negative infinity to positive infinity. What kind of asymptotes do we have? Horizontal. What would be the equation of that asymptote? Horizontal would be y equals 0. Okay. I would like for you guys to try the g of x equals 1/2 to the x. So graph it and then answer them. So if you plugged in, how many points do you think we really need to know what this graph looks like? 3. Which ones do you think we need? In Algebra 2, when we graphed those, we told you have to plug in -1, 0, and 1. And you can plug in more things if you need to. But that's your bare minimum, a positive, a negative, and 0. 1/2 to the -1, that negative exponent would flip it and you get out 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2. So we get -1, 2, 0, 1, and 1, 1/2. So our graph looks like this. Domain. Range. 0 to infinity. 0 gets parentheses because you never actually hit 0. Is this function increasing or decreasing? Decreasing from negative infinity to positive infinity. Any asymptotes? Okay, so tell me what's different between these two graphs. Just kind of flip, right? One's increasing and one's decreasing. They both have the same asymptote, same domain and range. They both hit the point 0, 1. So what determines if it's going to be increasing or decreasing? The base. If your base is bigger than 1, your function is increasing. If your base is smaller than 1, your function is decreasing. So just things that you want to keep in mind on these. You need to plug in a minimum of 3 points. -1, 0, and 1. If the base is bigger than 1, it should be increasing. If your base is smaller than 1, it should be decreasing. Domain and range are going to be the same every time. Domain negative infinity to infinity, range 0 to infinity. And you always have the same asymptote, the x-axis. Now, the thing that could change these would be, of course, transformations. So let's look at some of those. So for each of these, we are going to draw a graph and do domain and range. So if I said f of x equals a -3 to the x. Let's graph this, let's do parent functions and then apply transformations to them. So my parent function would just be 3 to the x. So if you wanted to graph that, your 3 points, -1, 0, and 1. 3 to the -1 would be 3 to the first, or sorry, 3 to the 0 is 1, and 3 to the first is 3. So I've got -1, 1/3, 0, 1, 1, 3. Remember, parent functions, we prefer dashed lines. You can certainly do more points, but you don't have to. Now, if I want to do transformations, what is a negative out in front doing to my graph? Flips it over the x-axis. So I'm just going to take each of these points, reflect them over the x. And so I get a very similar looking graph, it's just upside down. Domain. That'll be the case every time. Range here, we are hitting so because of the reflection, my range did change. Any questions there? Let's do some more. All of these I did with the same parent function, so we don't have to recreate that every time. My parent function was 3 to the x, so that the points were -1, 1/3, 0, 1, and 1, 3. What's the -2 doing to my graph? Yeah, if it's attached to the x, it moves left and right, does the opposite of what you think. So a minus will actually move it to the right. 2. Okay. Domain of this one would be the range would be 0 to infinity. Because we didn't move left and right, the range didn't change this time. Let's say I can give you guys one. How about you do this one? So graph it and give domain range. If your parent function is 2 to the x, what points are on your graph? -1, 1/2, 0, 1, and 1, 2. I will look to make sure you have those exact points. Transformation this time is 2. Okay, so move each of those left 1. We get this. Domain is still negative infinity to positive infinity. It will be every time. The range on this one didn't move, so just 0 to infinity. Okay, let's do a more complicated one. So same parent function as the last one, -1, 1/2, 0, 1, 1, 2. What will the negative on the x do? Flip over. If x is negative, that flips over the y-axis. And the -3 will move the whole thing down 3. So 2 pieces we have to do here. Alright, so if I take this point, flip it over the y, it goes to +1, 1/2, down 3. 0, 1, if you flip it over the y, doesn't go anywhere, then down 3. 1, 2, we go to -1, 2, and down 3. There's something else I need to move. We had a horizontal asymptote at 0. Since my graph went down 3, where is the horizontal asymptote now? Negative. So if you move up and down, you have to make sure to move your asymptote along with it. So domain, going from left to right. And range going from the bottom up. Is that all right? I want you guys to do this. Parent function has points -1, 4, 0, 1, and 1, 1, 4. -3, move the graph right 3. +4 will go up 4. I'm going to go ahead and move my asymptote. It's at the x-axis, so it's at 0 right now. If I move that up 4, my asymptote will move right here. So then take your points, right 3, and up 4. And if I ask for it, domain is still -infinity to +infinity. Range is just parentheses 4, comma infinity. Good? Let's do one last graph. Let's say I did -4 to the -x power. So parent function would have the points. If I put in a -1, you get 1/4. If I put in 0, you get 1. If I put in 1, you get 4. Does everyone know where I get those original points? What does the negative out in front of my function do? It's making all my y's negative, so it flips it over the x. The negative on my x is making my x negative, so it flips it over the y. So this one has 2 flips. You take your point, flip over the x, flip over the y. So we should get that graph. Domain always -infinity to +infinity. Range, we're hitting the negatives, so it's -infinity to 0. All right. really short lesson today. Are there any questions over this? I could really start the next piece, but I think we're just going to keep it as a really easy day, if that's okay with you guys, and give you time to get your homework done right now. So this assignment, you've probably got enough time to wrap this up. EOE means, okay, so you need to write them out, do that.